Hey Levins, what we're looking at here are simultaneous equations again, but this time by elimination. This can be sometimes a more versatile method. That substitution, I quite like substitution, but it can lead you to end up working with a number of fractions sometimes, so that you make one of, as a result of, making the one of the variables the subject of the equation. Now, with elimination, what we're trying to do is we are trying to somehow match the magnitude of the coefficients, plural, of one of the variables. So I want to have the same number in front of the x's or the same number in front of the y's, and I don't mind if it's a plus and a minus. In fact, I don't mind. They can both be the same, or they can be different signs, but I want the same magnitude. So I would like a, well, 3 and 3 would be good, or 4 and 4, but in fact what we're going to work for here is a 12 and 12. Notice over here, this is really nicely set up by elimination. Quite difficult to make either x or y the subject of those equations. Very easy, right, to match the coefficients. Already matched up in both cases. So that's going to be a nice example. This one, slightly less so. You need to explain what you're doing. I'm going to take equation, I'm going to do 4 times equation 1. Right, and that's going to give me 12x. 12x minus 8y equals 112. Yeah, I reckon that's a bit. Not 112, 116. 116. Okay, I'm going to call that 3. That's the first one. Next one, I'm going to do 3 lots of equation 2, and that gives me 12x plus 15y equals 24. Okay, you can see we've got 12x in both of them now. Why did I choose those numbers? Well, some lowest to common multiple, I guess, that kind of thing. We could do it with these ones, we could do it with the 2 and the 5, that would work as well. But we've decided to go this way. Now, I think if I do equation 3 minus equation 4. 3 minus 4, right? And what that gives me is 12x minus 12x, no x's. Negative 8 minus 15y's gives me negative 23y. 116 minus 24, that 92. Y equals negative 4. Halfway to the answer, right? Halfway, but not finished. All right, I wish I had a bit more space here, but I don't. Now I'm going to put that into, sub into 1. I'm just going to sneak in over here. Sub y equals negative 4 into equation number 1. Therefore, 3x minus 2 times negative 4, so minus negative 8, so plus 8 equals 29. That will tell me 3x equals 21. That tells me x equals 7. Okay, there's my two answers. There's my two parts. X equals 7, y equals negative 4. That's a pretty messy example, but there's not a good way to do that. We do get a fairly neat answer at the end. There's not a really nice, easy way of doing that one. These ones here, this is fine, 1 and 2. Now we can either choose to add them together or subtract them from each other. So, let's go equation, just to be different. I'm going to go equation 1 plus equation 2. Right, we subtracted before. Let's add them together this time. What happens to add them together? I get 2x squared equals 98. Therefore, x squared is 49. For x equals plus or minus 7. Don't forget the minus possibly, because negative 7 works there as well. Now, let x equal 7. Therefore, I'm going to substitute into one of these. Let's say 49 minus y squared equals 45. So that suggests to me that y squared equals 4, then y equals plus or minus 2. Y equals plus or minus 2. So if x equals 7, y could be 2 or 7. Right? I'm looking at quite a few results here. Now, let x equal negative 7. Right, substituting again, negative 7 squared is still 49. Y equals plus or minus 2. So my solutions. Right, remember, I can have 7 and 2, 7 and minus 2, negative 7 and 2. Oh, wait, I should substitute in here, therefore I get 49. Again, right, minus y squared equals 45. Y equals plus or minus 2. My solutions are 7, 2, 7, negative 2, negative 7, 2, and negative 7, negative 2. We get 4 different solutions for those. Right, 4 different solutions for those. That's pretty complicated, nonetheless. That is solving simultaneous equations by elimination. Check it out. We'll work through them in class. You can have a look here at 3 simultaneous equations. We'll save that for class, definitely. Okay, thanks very much, guys. Good work.